If you've mastered or mixed music in the past 20 years, odds are you've used a limiter. Their use or misuse has shaped the sound of records and singles for decades, contributed to the notorious loudness wars, and completely altered listeners' expectations for dynamics. However, what if I told you that limiters won't just be phased out in the near future, but that the processing that they impart is already obsolete? Now, this isn't because of loudness normalization or a shift in standards, but due to processors and methods that already exist that sound better than limiting. So, let's jump into why you should stop limiting your masters. Starting off, let's briefly cover how limiters work and the issues with their design. Now, modern limiters or brick wall limiters utilize look-ahead. When enabled, latency is introduced, and this allows the processor to measure the peaks of the signal before processing. With this info, it knows when to attenuate the signal without the need for an attack time. It doesn't clip the peak like a clipper does, it reduces the gain of the peak right when that peak occurs. It's not reacting like a typical compressor, it's already mapped out how it will alter the signal. Now, most limiters allow for amplifying the signal into the limiter, which is the only real benefit of the processor. The quieter parts are amplified, causing a louder sound, which is generally preferred by people, and it reduces masking to quieter details. Now, look-ahead guided attenuation causes less harmonic distortion than clipping since the wave is shaped to a lesser extent, but it affects transients in a distinctly unpleasant way. You may have noticed that limiters reduce the impact of transients, causing a blurred sound. Now, some limiters are better sounding than others, but the algorithm that they use is really what changes the sound. The release time and shape, the attack shape, if transients are expanded post-attenuation, if oversampling increases the accuracy of amplitude detection, if the channels are attenuated in tandem or processed independently, and so on. All affect the limiter's sound. But here's the point. If all we need to do is amplify quieter details, there are much better ways to do this than by using look-ahead attenuation on the peaks. If your goal is to create a dense, detail-rich, and nuanced sound, but without messing up transients, then stop limiting. Limiting will always affect the transients by altering the amplitude of peaks. That's what they're designed to do. Now, this all makes sense, but aside from clipping, what's a good alternative? And this brings me into mastering with various dynamics processors. So all of the benefits of limiting can be accomplished with parallel compression, maximization, and careful monitoring of the peaks. Let's take a look at this graph. The x-axis is the input, and the y-axis is the output. If a limiter pushes the input until the loudest parts hit 0 dB, or a set ceiling, then I want to try pushing the input while leaving the loudest parts alone. That is, to take the input of every aspect of the signal that's below, say, negative 10 dB, and amplify it while leaving everything above negative 10 dB alone. If I continue to push up these quieter details while leaving the peaks alone, I can achieve the same loudness as limiting, but without the need for attenuating peaks. Now, the most common method for this is parallel compression. If I use this Pro C2 plugin and compress heavily, you'll notice that the peaks are attenuated. However, if I blend in the dry signal so that I achieve equal parts wet and dry, notice how the peaks are unaffected, while quieter details are amplified. Additionally, I can vary what gets amplified and to what extent by adjusting the knee, the threshold, the ratio, and other parameters like the algorithm or the compressor type. Although the peaks will still be affected, it's only to half of the signal, since half of the output is the original, unprocessed signal. It's not perfect, but it allows for much less noticeable attenuation to peaks while introducing all of the detail and the loudness that we'd achieve from limiting. Furthermore, since we don't need to worry about clipping and subsequently don't need an instant attack, we can vary the attack and the release times to optimize transient retention. Also, if you're worried about harmonic distortion, bus or mastering algorithms are going to work well at reducing that. Or you could try different models out to find some distortion that suits the track well. With other plugins, you might need to combine the wet-dry and the output to achieve a similar effect, but I recommend this plugin if you plan on using parallel compression while you're mastering. I'm going to cover some different methods in just a moment, but for now, let's compare limiting and parallel compression. I'll set both to the same loudness so that we can more easily tell the difference.
I'm feeling high when I'm low. I need it more when you're close. I'm feeling high when I'm low. I need it more when you're close.
Make mixes that accurately translate what you hear in your head without years of practice or expensive plugins. Seriously though, when people work with us, they get results. That's why major industry professionals like Keith Urban's producer Aaron Schurz works with us, Grammy Award-winning AJ Castillo, Billboard #1 charted artist Megan Lindsay, Grammy Award-winning artist Toulis, The Voice singer Cody Ballou, Grammy-nominated producer Tyler Kane, Warner Music artist Ricky Young, and the list goes on. Why waste your time creating mixes that look like this when you can instantly fix the problem by working directly with professionals who have already done what you're trying to do? Watch this entire video, and at the end, learn how you can start making mixes that accurately translate what you hear in your head. Another form of processing to try instead of limiting is maximization. And to keep things from being confusing, iZotope's Maximizer is a limiter. It maximizes in the same way that all limiters do. That is, amplifying the input uniformly until the ceiling is hit and look-ahead brick wall attenuation is used on the peaks. Now, a maximizer like the Oxford Inflator pushes quieter signals upward before slowly reducing the amplitude as it reaches 0 dB. Now, some people call this a soft clipper, but looking at the waveforms, it seems like it imparts more gradual wave shaping, not squaring the waves like a clipper does, just amplifying quieter details. Now, another great option is Vintage Warmer 2 by PSP. Its knee function is basically a control for amplifying quieter details. Like the Inflator, compression only begins at a higher amplitude, and even then, it's very subtle. Unlike other limiters, the brick wall function can be turned off, allowing for a careful balance between maximization and monitoring peaks. If we lower the input drive by -4 dB and increase the knee, we can achieve a lot of maximization without any attenuation until -12 dB and no significant attenuation until about -3 dB. Furthermore, we could vary the mix to incorporate more of the dry signal, resulting in additional transient detail, again, while achieving all the benefits that would come from brick wall limiting. Now lastly for this video, although I'm sure there are a lot more plugins you could use for this purpose, let's cover Saturn II. So Saturn II offers subtle settings, like subtle tube or subtle tape, that when combined with the dynamic style, can achieve a similar effect. It's almost the same as the parallel compression effect that we got when we were using the dry dial of the Pro C2, but without the need for attenuating the signal first. The drive function of the plugin isn't even needed unless you want to impart more harmonics. Also, since this plugin allows for multiple bands that are processed separately, we could introduce varying levels of maximization to different frequency ranges. And in case you're worried about varying the mix style or maybe some aliasing distortion, both oversampling and linear phase processing are available with this plugin. So, all of this to show, we have multiple alternatives to limiting, all of which amplify lower amplitude ranges without the need for peak attenuation, or in the case of parallel compression, peak attenuation that can be controlled and made to sound much better than limiting. So, let's compare limiting with these three processors that I mentioned. Notice we can achieve a competitively loud and upfront sound without the need for brick wall limiting.
I'm feeling high when I'm low. I need it more when you're close. I'm feeling high when I'm low. I need it more when you're close. I'm feeling high when I'm low. I need it more when you're close. I'm feeling high when I'm low. I need it more when you're close.
Make mixes that accurately translate what you hear in your head, without years of practice or expensive plugins. Seriously though, when people work with us, they get results. That's why major industry professionals like Keith Urban's producer Aaron Schurz works with us, Grammy Award-winning AJ Castillo, Billboard #1 charted artist Megan Lindsay, Grammy Award-winning artist Toulis, The Voice singer Cody Ballou, Grammy-nominated producer Tyler Kane, Warner Music artist Ricky Young, and the list goes on. Why waste your time creating mixes that look like this when you can instantly fix the problem by clicking the link in the description and working directly with professionals who have already done what you're trying to do? We've helped 2,346 clients make mixes that accurately translate what they hear in their heads without years of practice or expensive plugins, and it'll work for you too. Click the link in the description and get direct access to us for custom analog mastering, one-on-one mixing feedback, in-depth mixing and mastering courses, and our thriving community. Click the link in the description now to start making mixes that accurately translate what you hear in your head.